Everyone, this is NetMaven. Today we're going to make a deployment about Cisco Nexus Dashboard 4.0. Nexus Dashboard is designed for this lab VXLAN EVPN multi-site deployment. You might have seen the similar video about this topology. This time we're going to make this in the Nexus Dashboard 4.0. Cisco Nexus Dashboard, also called Fabric Controller, offers the network management system NMS, and it supports for traditional and multi-tenant LAN and SAN fabric on a single window, single pane of glass. Cisco NDS Nexus Dashboard Controller works across all Cisco Nexus and MDS switching families. It manages a large number of devices that were providing ready-to-use control, management, and automation. Also supports automatic configure for multi-tenant automation. It gives you intuitive multi-fabric topology views for LAN fabric and storage. This lab will be focusing on building the multi-site VXLAN EVPN topology. We have is the Greenfield and the Brownfield, site 1 and site 2, and they're in the fabric virtual extensible LAN VXLAN, which is an overlay technology for network virtualization. It provides a layer 2 extension over a shared layer 3 underlay infrastructure network by just using a MAC address in IP UDP. Tunnel encapsulation. So this purpose of obtaining an L2 extension in overlay network is to overcome the limitation of physical server racks and the geographical location boundaries to achieve the flexibility for workload placements within the data center, or we could do it between the data center. So in IETF VXLAN standard, there's RFC 7348 defines the multicast-based flood and learn without the control plane. It relies on the data-based flow and learn behavior for remote VXLAN tunnel endpoints, which are called VTAPs, peer direct discovery, and remote and host learning. So this overlay broadcast unknown unicast multicast traffic, we all called the bomb traffic, are these are encapsulated into a multicast VXLAN packets and transport to remote VTAP switch through the underlay multicast forwarding. Flooding in such deployments can present a challenge for scalability of the solution. So the requirement is to enable multicast capabilities in the underlay network. Also presents a challenge because some companies don't want to enable multicast in the data centers or WAN networks. To overcome the limitations of flood and learn, and some companies can use multi-protocol BGP Ethernet VPN. So what is it called? It's called MP multi-protocol BGP for EVPN as the control plane for the VXLAN. The IETF defines MP BGP EVPN as a standard-based control plane for VXLAN overlays. The MP BGP EVPN control plane It provides a protocol-based VTP, VTAP, peer discovery, and in-host reachability information distribution that allows more scalable VXLAN overlay network that designs suitable for the private and public clouds. The MPBGP control plane introduced a set of features that reduces and eliminates traffic flooding in the overlay network and enables the optimal forwarding for both east to west and north-south traffic. Okay, this topology is for the multi-site. VXLAN EVPN multi-site is a solution to interconnect two or more BGP-based Ethernet VPN, EVPN site fabrics in a scalable fashion over an IP only network called ISN. The border gateways in here, border gateways is the nodes that interact with nodes within the sites and within the sites inside, right, inside, and interact with externally to different sites. For example, the leaf spines here. Data center, we have a spine, and the leaf is called a border leaf. It can be like a spines and a leaf, and a separate device acting as a gateway is also a part of a leaf to interact with different sites or external sites. Let's see a new diagram here. In this lab, we would use what we called Nexus Dashboard and Fabric Controller and the FC server. In the Greenfield, for the Greenfield and for the Brownfield. The Greenfield uses to provision new EVPN VXLAN fabric. We're going to import and deploy VXLAN EVPN fabric on Greenfield, and we'll create a brand new and logical interface. In this case, there's a VPC from my Site 1 Leaf 1 and Site 1 Leaf 2. It's going to be a VCC pair, and the border leaf switch is a border leaf. We'll talk about this. Border leaf, Site 1 border leaf 1 is in place here to provide external L3 connectivity using VRF. We're going to use in the VRF Lite. And we want to extend classic Ethernet network to a VXLAN BGP EVPN fabric, including migrating the first hop gateway, which in turn to facilitate the more workload. We want to migrate this and to my fabric. The further step to extend this will be all my classic state DC. We want to migrate the servers here to my fabric. Let's get rid of the drawing here for Greenfield, and then we'll talk about the Brownfield. The Brownfield is tell us how to migrate an existing VXLAN EVPN BGP fabric to NDFC. So it's already built and existing, created by CLI, command line, whatever. We don't have the NDFC beforehand. So this transition will involve migrating existing network configuration to my Nexus Dashboard Fabric Controller. Typically, I create and manage my fabric using like I talked about, we're using CLI, already created all this, or customer automation scripts. I did my configuration, I put a configuration with all of these nodes, border leaf, spine, leaf, all these in my command line. Now I can manage the fabric. All this will be showing as a fabric, brownfield fabric. It's gonna be showing as a fabric site. We can manage the fabric underlay overlay networks and import, deploy the brownfield into my fabric controller. And we'll remove the bulk creation of network VF scenario in this version. We'll import and deploy the brownfield into the dashboard. After we have a greenfield and a brownfield fabric site, we would be creating a core fabric. Well, then we're gonna move to creating the multi-site. A multi-site fabric container will be created to manage multiple member of fabric. It is a single point of control for a definition of overlay network and virtual routing forwarding via VXLAN member fabric will be sharing. So then we'll configure. Lastly, we'll be doing a little bit of we'll call it endpoint locator. We'll call it EPL, endpoint locator. This feature allows real-time tracking of endpoints within a data center. The tracking includes tracking the network life history of an endpoints, for example, the endpoints here, and we're getting the insight into the trends that are associated with the endpoint additions, removals, and move, and so forth. An endpoint is anything with the IP and MAC addresses. In essence, an endpoint can be virtual machine. It can be a virtual machine, right? It can be bare metal, and or it can be a service appliance. It can be appliance, anything. Let's also look at the first step is to import and deploy VXLAN EVPN fabric on a Greenfield. We're going to import Greenfield. We're going to import a clean fabric and create VXLAN BGP EVPN for my Site 1 Greenfield using Nexus Dashboard. Nexus Dashboard clears all configurations on the switches except the measurements before pushing VXLAN EVPN configs on the switches. The first day zero step in Nexus Dashboard's lifecycle management of my Greenfield fabric is to create the fabric where I define the fabric settings such as the BGP AS number, and we're going to define the replicate mode for the bomb traffic, and we'll define the IGP for the underlay, our subnetting scheme, and for the underlay interface we'll have the subnet, and we'll have to define the VTAP interface, and all other settings. I will achieve this configuration of fabric using a powerful, flexible, and customizable template-based framework. With the minimum user inputs, I can bring up an entire fabric with Cisco recommended best practice configuration in a short time period. The set of parameters exposed when creating the fabric in the fabric setting allow me to tailor the fabric to their preferred underlay provision options. Let's now do it. Click Manage it and over to Fabric. Here we're gonna create a fabric. We're gonna select Create New LAN Fabric. Then click next. 4.0 is different interface. We're going to select VXLAN with a subtype as to data center VXLAN EVPN. Okay, here we have VXLAN, classic LAN, AIML is the automated VXLAN fabric using AIML. Here, external and inter-fabric ISA network, routers, IP fabric for media, all of that thing. Okay, click VXLAN. We're gonna pick is data center VXLAN EVPN. Or could use campus VXLAN EVPN. Here is mentioned iBGP. Okay, click next. For the fabric settings, we're gonna set as advanced. The fabric name will give as site 1, say Greenfield. San Jose, US. Okay, we're gonna make it is BGP, like the iBGP overlay routing protocol. iBGP, okay. We're not using any, VPC, so we're good with iBGP for now. 65111, that's what I defined for the ASN number. The license tier for fabric, we want to use a Premier. And enable features, telemetry, uncheck this. Make sure you uncheck this. Okay. Here's the overview, take a look. Let's now close this, click next. Under advanced settings, find the general perimeter tab. For underlay subnet mask, here we want to use 31, save some IPs. We're going to select replication. Here, replication, okay. We're going to change underlay RP loopback IP to 251. Okay. switches and assign a role to these switches. How you assign the switches is to click the action and add a switch. When you add a switch, make sure you assign the role to the switches border leaf, border gateway leaf, and assign the spine to be a spines. After that, we're gonna configure the access interface to the servers. Here we have a few servers connecting to my leaf 1 and leaf 2. How we do that? We're going to enter the filter. We want to do the first is Ethernet 1/5. We're going to say interface equals to Ethernet 1/5. And we have a leaf 2 also is 1/5 connecting to server 1 and server 2. This is where we're going to find the interfaces on the switches. Look for Ethernet 1/5 on leaf interfaces. We're going to take action, edit configuration. Under the policy, click policy. We want to use policy interface access host. Select this policy, and I'm going to select and save to next. Click deploy. Right here, as I expected to configure 8 lines. This is what we have. Okay. Click deploy configs. Now, the next task is to create VPC pairing. We have VPC leaf 1, leaf 2, which is our VPC domain. And we're going to perform this task for my site 1 Greenfield fabric. I will make my site 1 leaf 1 and site 1 leaf 2 a VPC pair. Or say in classic way, we would say this is VPC domain, okay? For the switches tab, we wanted to create a VPC pair between the switches just by working with only one of the switches in the pair. The dashboard automatically will detect the pair for us. Let's go to Manager, and the fabric will be in the site 1 Greenfield, and click Inventory. And here is the switches sub tab, right? We're gonna click site 1, leaf 1, site 1, leaf 2. Click Action. Here is Action. We're gonna Action. So now it says out of sync. That's okay. We're gonna to recalculate. Let's see if we can make synchronize. Deploy all. Alright, close this. When I deploy as success, go back to my inventory. We're going to click only leaf 1. Action is to create a VPC pairing. In the VPC pairing pop-up, we're going to locate, we want to be pairing with site 1 leaf 2. Okay. We don't want a virtual pair link. We use management port. Okay, site 1 leaf 2 will show as set to true, and only recommend switch the cable of being a peer because it is connected to site 1 leaf 1. After that, click Save. When you receive this message, click OK. This time we're going to do other, recalculate and deploy. Alright, site 1 leaf 1, leaf 2, obviously they are ready for my VPC pair. Here's the configured. It detects the Ethernet 1314 as the as my peer link. If you choose to be virtual peer link, you don't need this. You could use the entire fabric as your peer link. This is called virtual peer link. Okay, we're not doing this lab, and we can see the detect as a peer link 1/3 and 1/4. VPC domain is created for you. and is utilizing my management ports for peer keep alive. These on my standard template config. Click deploy all. You understand the config, that's fine. Let's close this. We deployed it. Next, we'll be able to create is the VRF. It's to set up inter VXLAN routing with a symmetric integrated routing and a bridge. We call IRB. When I need an L3 virtual network identifier, which is VNI, and it's gonna be my layer 3 for inter VNI routing. That is deployed in an overlay or tenant network, and layer 3 VNI links to a tenant VRF, which helps separate the routing domain between tenant overlays. The Nexus Dashboard simplifies this process just by automating configuration checks. We're going to make sure all VRF, BGP, EVPN, and VXLAN settings are correct. If you configure this in a CI, it's going to be a lot configurations. So this is particularly useful in a large production environment with many peers and tenants overlays. So where the managing the configuration can be very complex. So I will create and set up the initial tenants with overlay VRF, this step, and I will associate this to an L3 VNI, layer 3 VNI. In next, I will follow the workflow to create networks that consist the L2 VNI and VLANs. Map out to a VLAN. And we're gonna link then to an overlay tenant VRF. So all that step, go to fabric overview for my site 1 Greenfield page. We're gonna click is segmentation and security. Then in the VRF tab, we're going to create action. We're going to be creating a VRF called blue VRF. 50,000 is fine for my VRF ID. You gotta be an ID, right? Let's click propose VLAN. It proposed me 2,000, sorry. 2,000, that's okay. And in general parameters here, we say blue VRF, copy that, description blue VRF description blue VRF. We like it, and click create. Now, in Nexus Dashboard, networks are where I set up the L2 virtual network L2 VNI. So it's in L2 VNI, sorry, we just make it more clear here. L2 VNI is in Nexus Dashboard called networks. The networks is L2 VNI in dashboards. We'll link the L2 VNI to VLANs for layer 2 segmentation, or we call bridge domains, across the routed fabrics. So L2 VNIs keep layer 2 traffic within their boundaries, preventing it from crossing into other VNI. For routing between different VNIs or VXLANs, so L3 VNI with a VRF is necessary. If routing is needed, you can set up a switched virtual interface. We call it SVI interface. Also known as Anycast gateway. On all leaf switches, which I then associate with the layer 3 VNI VF, if a routing between L2 VNIs is not required, L2 VNI can just remain as layer 2 only. This lab, I will set up 2 networks for inter-VNI routing. We're connecting them to the layer 3 VNI VF I created earlier. What I created earlier is VRF. You have to call it blue net. We're creating 2 is L3. L2 will be routed by my blue net VRF. The name of my L2 VNI is gonna be networks. Well, networks. It's called blue net 1 and blue net 2. Okay, this is how we're gonna create. We're gonna navigate to the networks after VRF. Take action. We'll create the first network. It's gonna be my blue net 1. Leave this layer 2 only unchecked, because if you need L2 only, just click L2 only. But I'm going to associate VRF. You won't see this if I click L2 only. It just doesn't make sense if you have VRF. We need a routing, so we are creating is associated with blue VRF. Well, network ID is populated automatically, and propose a VLAN that's 2300. Okay, and create a gateway 192.168.11.124. VLAN name, say blue net 1. Interface description, blue net 1. Will be clicking create. Let's create next is my second network. Next second is automatically populated at VNI 30001. Propose a VLAN for this 2301. Okay, let's say it's called blue net 2. Okay, we need an IP. Instead of 11, we'll make it 12.1. VLAN name, BlueNet 2, description, BlueNet 2. That's what we wanted. Create, next. Okay, 2 network created. All right, we don't want this name. We want to, let's say, edit. Can we edit? Yes. BlueNet 2. BlueNet 2. Okay, save that. Change the name. BlueNet 2. Here we create BlueNet 1, BlueNet 2. We have redraw the idea, the drawing like this. We created VRF, BlueNet, create 2 network, BlueNet 1, BlueNet 2, and these 30,000 and 30,001 are their VL2 VNI. In Nexus Dashboard, VRF and network attachments can happen independently. I create VRF and we'll attach them to the leaf switch. We're going to attach them to switch. And then we'll create a network, then attach them to the leaf switches. I can combine the workflow, and where I create the VRF, then associate the networks to the VRF. And finally, we'll deploy network, which deploy the VRF, and all this sticking to the Cisco best practices. We'll have a staged overlay tenant VF, and stage 2 here host networks that are associated to my overlay tenant VF. In the previous lab, this is what we have done. And this time we're going to attach the list structures to the leaf switches that are required. The requirement comes based on the design of how the host, such as the EXSI, connect to my leaf switches. There are 2 standalone Linux instances. These instances connected to my leaf 1, leaf 2 on Ethernet 1/5. Okay, so this is the interfaces that I used a policy to configure as access interface, leaving the access VLAN undefined. Another part, this we already defined as access, right? This access, we don't have a VLAN defined. Other part of the attachment workflow is selecting interfaces for networks that I deploy. So whether it is an access or trunk interface, we have to attach. So I will select my Ethernet 1/5 between my 2 leaf switches for each network. I created previously. So go to the first network. We're going to attach the first network to leaf 1 Ethernet 1/5. So we're going to double click the bootnet 1, attach this. Click network attachment tab. We're going to now pick the switch. We're going to pick, we have these other switches. We're going to pick side 1, leaf 1. In the side, we want to say edit. One quick attach, say attach. We want to attach to Ethernet, which is access interface. Attach this, click save. Then this network bootnet 1. Make sure this bootnet 1 will attach to this interface. Okay. Now let's just close this window. We'll then attach the second network to side leaf 2, the second bootnet 2. We'll attach to this interface. Close. Let's double click bootnet 2. Now attachment. So find the switch, side 1, leaf 2. We'll click action, edit. Okay, attach. Attach which interface 1/5. You'll notice the 1/5 is still port. Type is trunk. We can change that after. Click save for now. Oh, I missed that deployment. We're gonna fix this. Okay. Close that. Close. Remember how to do that? Go to connectivity. In interface, we're gonna filter. Interface. Let's do one more time. On leave 1 is already access. Click next. Okay. There's network attached. Detach. Close that. Let's get refreshed and find E15 on leave 2 once again. Click edit this config. Now I can change access, save. Deploy. Right, it shows access. We're going to attach blue net 2 to this interface once again. That works. net 2. Here is okay. Double click it. Side 1, leave 2. Pick the switch, edit, attach, (1/5), which shows access, save. Now I attached networks that are pending deployment in the Nexus Dashboard. So it is time to deploy. There you go. Deploy all. When complete, let's close this. To see the network deployed, we're going to navigate to segment and security, then networks. When performing action to deploy network attachment, the intent is for my VF to deploy at the same time because of the VF association with the network when I create it. We're going to confirm that VF is also deployed to the top navigation. Click VF. We're going to see blue VF, it shows deployed, is deployed status. So along with this VF together, everything's deployed to the port. Now through the Nexus dashboards that I have created and deployed my Side 1 Greenfield VXLAN EVPN fabric and performed a level of verification just by checking the status deployment and that the Nexus dashboard reports. Now I'm going to connect some devices to the Side 1 fabric to issue some commands to verify the configuration Nexus dashboard deployed by Nexus dashboard. Alright. Also, we're going to use Linux servers that are connected to my Side 1. Leave 1 and Side 1, leave 2. They are server 1 and server 2. I will perform data plane verification by checking the connectivity to my Anycast gateway, and we're checking the inter VXLAN routing between my two servers. Log into the spine. Spine here, we're going to verify the underlay OSPF neighbor, show IP OSPF neighbor for neighbor in for status, and we're going to show BGP EVPN neighbor, show BGP L2 VPN, show BGP L2 VPN EVPN summary, neighbors up, and we'll verify side 1 leaf 1. Here we go, side 1 leaf 1, show VPC. Want to see VPC shows up, and it appears live. Everything is success. We want to show MVE VNI. We can see the L2 VNI, L3 VNI, blue VF. Right? We're gonna say there are two Linux server. Server 1 and server 2 connected to my leaf 1 Ethernet 1/5 and leaf 2 Ethernet 1/5 respectively, and I'll use these to test the inter VXLAN data plane connectivity within the same tenant overlay VF in my side 1 fabric. Just ping server 1 to server 2. Okay. Let's log on to server 1. We're gonna ping. Okay, our ping is okay. IP config. Its own IP is in the other VNI. BlueNet 1, right? It's BlueNet 1, BlueNet 2 is crossing the VNI to ping. And last thing we're gonna show you is return to the dashboard. We're gonna close everything here. Go to home, topology. We're gonna double click this side 1 Greenfield. We're gonna check on configuration sync status toggle. When all switches are green, you see all switches are green, they are synchronized, and you can hover on link or switch to see more details. Alright, this is my part 1. We create and deploy the attachment via after network and change the interface to access to the endpoints and do the series of verification. They are all success. Next time we'll move on to import and deploy Brownfield into Nexus Dashboard. Is my next video. Stay tuned. Until see you next time.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.